So this is Altair Access, part of previous work suite. It's connected to my organizational identity access management. Okay, so I'm going to just use my username password that I use for my email or for my Windows login. I can just go ahead and do that. I'm presented with a neat interface. This reminds probably of your cloud drives. I mean, like if you've been using um, Google Drive or OneDrive, this is very similar to that, except that it kind of handles your simulation data. This transparently exposes your storage that is connected to the HPC. So there is no copying of data from back and forth. It's directly on your HPC. Okay, and if you have certain files that's residing on your laptop and you want to upload them, you could do that. You could just go ahead and say upload files. And do I have a file that is interesting for you guys? Yes. So I could just go ahead and say upload, and it's actually uploading files here. It's wire speed. There is absolutely no overhead of the software stack. It's about 10 MB file. I mean, like on a decent internet, home internet, that was pretty fair. I couldn't ask for more. Okay, so the file is there. I could run my simulations now. Yeah. So say for example, this is a door oil canning simulation. I'm going to run the simulation using OptiStruct. This is a non-linear problem. Okay. So let's see if I can run this simulation using the HPC that I have in my office and probably post-process the results. And let's take this workflow and see what happens. Yeah. So when I click on the .fem file, it understands it's an OptiStruct input file, and it provides me with only the options that can be used with this file. Okay. So I get a lot of OptiStruct. So I'm going to choose my favorite profile. It sets up everything for me. Okay. So it says that, yeah, you're going to run this on the HyperWorks Unlimited server. You're going to use 2019.1 version. You're going to use domain decomposition model. You're going to use hybrid MPI method. So total of 20 cores would be used. One whole server was what I'm subscribing to. And I'm saying that you should use about 4 GB of RAM and 40 GB of disk. That's my resource allocation to this job. So go ahead and submit it. I get an acknowledgement number. I click on that, and you'll be able to immediately see that the job is running. Okay, so there was enough resources for me to run. It has started running. It has gone into one of the servers in the cluster, and you can actually see the output files right here. So I probably want to see how the simulation is proceeding. So what I'll do is go ahead and open it with a text editor. Another cool feature is that I can watch this file, and I mean, like when it starts the iteration, it would give me the delta updates. It's pretty efficient. It is only taking the delta updates from the files, and it's going to highlight to you and show you what exactly has changed between the last time it fetched your file and this time. Okay, it's pretty neat, pretty cool. All your iterations right here. Okay, so let's allow this simulation to proceed. It takes about 5 minutes to finish. Okay, so but just in case, what I did was to probably have one of these simulations already ready for you. Okay, so this is something that I ran, and the H3D file is available for me now. So I'm going to just do the same thing, right click on the file. This time it knows that it is not a simulation input file. Instead, it is a result file. So it is giving you appropriate options here. Okay, so I'm going to say open it with Hyperview. This is going to open a VDI session straight on your HPC cluster. Okay, so the requirement is that you need to have at least one graphics card to get this done. Okay, so now your result files are directly opened on your web browser. There's absolutely no additional requirement for installing a client. You don't have to be dependent on your IT department. Absolutely nothing. Okay, so if you can access your Gmail, you can access your results. Okay, that's as simple as it. So let's go ahead and see what we can do with this. This is a door oil canning model. So technically, I mean, I'm not a CAE specialist. Okay, so this is I learned it from my peers. So very simple. This is a car door. What you're going to do is you're going to push the middle of the door with your fist, okay, and you're going to see what kind of displacements happens, okay. So let us go ahead and process this. We're going to see the displacement value. Okay, let's go ahead, apply this. This is a loading case, which means I'm pressing my fist against the door. Okay, perfect. So that's what happens when you press your fist against a door. And I know this is a pretty simple model, but then it kind of demonstrates the power of the stack, the power of PPS works, and the ability to give access to your simulation data. Okay, so for the interest of completion, we'll also do unloading visualization, which means you're taking the fist off the door and what happens. Okay. So pretty neat. So I could just go full screen and you would probably not even realize that you are working out of a browser. So this is going to be absolutely native. You will get your native application experience. Okay, so you would not know that you're working on a remote system.